7 common dovetail mistakes. Thanks for tuning in. Today, I wanted to share a post I was reading by Harvey Tool, where they break down the 7 common mistakes in dovetailing, and I know I've been guilty of at least a few of these over the years. Let's check it out. I'm going to put a link to this article so you can check it out for yourselves and actually sign up for their mailing list. Harvey has a fantastic value that they love to add to the industry. They're only ever emailing about brand new releases of their products, so you're up to date, as well as tips and tricks, just like what we're going to go over today. All right, let's check it out. Dovetails are not new, but there is a trend towards miniaturization in the industry. And one of the things that happens when you take something you're used to doing on a large scale and make it smaller is that mistakes and other things that we get away with on the large diameters no longer hold up. The tools just are not large enough to take, our ignorance anymore, and they break. So let's go over these 7 points together. Anytime you're implementing a new tool, avoiding tool failure is kind of par for the course. They do add up. And one of the things that I know I did in the beginning is I used to program dovetails off the largest part of the diameter when I was milling. And I mean, it worked, for 5/8 and 1/2 inch and larger tools cutting big dovetails, it's not a big deal. The trend towards miniaturization amplifies this fact, and suddenly what we could deal with and bear for tool life is no longer acceptable. The first one we're looking at is not taking advantage of drop holes. I know in my career, there's been times where drop holes weren't allowed on the print initially. However, when I had a conversation with the engineer, they were happy to make accommodations when they realized the effect of the cost on the part when there's no entry hole available. If there's no entry hole allowed for your dovetail process, you're spending a lot of extra money on your cycle time because now you've got to use a smaller tool. As I was saying in the beginning with the larger tools, this wasn't so apparent. Now as we go smaller, if you're programming off the wrong neck diameter, there's going to be big issues. Programming, you have a variable that you're not taking into your calculations, and you're going to break tools, you're going to struggle, and you're going to wonder why it doesn't actually work out to the manufacturer's recommendations. This error of using the wrong diameter to program your tool compounds as we go through our calculations, and the error will usually result in the loss of a tool. Aside from the cost of the tool, you have possible setbacks if you happen to only get 1 or 2 and you don't figure it out before they're gone. One of the points to consider is your radial depth of cut. I mean, when we're doing dovetails, there's no variable for your axial depth of cut. However, you do need to consider your step over amount, and it needs to incrementally decrease as you step out further because the amount of surface area that you contact, right? So when you're on that taper and you're slowly stepping into the wall, now you've got more and more and more of your taper coming into surface contact. And if you don't accommodate that for that in the amount of your radial step over, then you're going to come across vibration and all kinds of other nasty bits that you definitely don't want in a sealing surface. It may seem obvious when it comes to working with delicate tools. However, it's worth to note that climb milling is not your friend when you're working with miniature tools. This is further amplified when you're working with a dovetail cutter that has a large diameter, translating extra torque to a smaller diameter during the cutting process. Not taking consideration for when you're flushing the chips. You might be thinking, yeah, I always put coolant in there. With these small tools, the smaller you go. Now, we're talking about dovetails today, but this would apply to your end mills, your drills, anything really, really tiny. If you've got through spindle coolant, that's not as much of a concern. But when you're shooting the coolant at the side and you're using a small tool like this in the case of dovetails, you want to make sure that you're pointing it with hopefully adjustable flow. If not, you can get some lock line to put on there to toggle your flow. And you want to adjust it so it's just ahead and just behind, and you want to have the pressure adjusted so it's not too hard. You might be asking, why go through all of that? 1, we don't want to recut chips, especially with a miniature tool. 2, you want to make sure that you're not putting excessive coolant pressure on the tool because that will cause deflection, vibration, resonance, breakage. All bad things. Number 7, are you giving the job away? If you're looking at small miniature dovetails through the lens of a large dovetail, you you could end up giving the job away because you're not quoting enough hours to get the finish requirements met, and considering for the smaller tool and the variable radial depth of cut and the other points we've talked before number 7. Don't forget to check the comments below for a link to this article so you can read all of this, and do sign up for the Harvey newsletter and make sure you subscribe to them here on LinkedIn. They're always putting out a lot of value for all of you to apply and save you time and money. Until next time, keep your spindles turning and earning.